Hi guys, welcome back. In this chapter, we will integrate Qt in our image. We will explore very briefly what Qt consists of for those who aren't familiar with it. After that, we go through each practical step in order to configure and install Qt. We will also install an example Qt application, executing it on system boot up. Finally, we will also be able to cross-develop and easily deploy Qt applications from the comfort of our workstation. Okay, let's get into it in the next section. Okay, so what is Qt? Qt is a cross-platform framework that is used as a GUI development toolkit. It is supported across many platforms, including Android, Linux, and Windows. It is also quite popular in the embedded world due to its relatively slim runtime requirements and good performance. It also has a generous and well-maintained library, documentation, support, and several integrations, for instance, within the automotive industry. The core components of Qt are mostly C++ components, but it also has QtQuick, which is a framework that combines QML and JavaScript while providing an easy integration with C++. QML, which is a Qt modeling language, is a markup language for designing user interfaces and is sometimes compared to CSS. Qt also has bindings with other languages such as Python. Apart from the UI development, Qt includes numerous modules such as Qt Core, which I personally sometimes compare to the standard libraries you might find in a programming language, because it provides containers, thread management, event and signal management, among others. There is Qt Network, which provides an abstraction for network programming. There are many other modules such as Qt WebKit, Qt SQL, Qt Serial Port, and so on. There are also other technologies available, such as Qt Automotive Suite, which is a collection of software components and tools that enable you to develop standard in-vehicle infotainment systems. Being a complete app development framework, Qt includes many moving parts such as the graphical backend and user support. For instance, it supports its own virtual keyboard, and alongside with other aspects such as network encryption and so on. So when building and integrating support for the Qt framework in our platform, we have several configuration options. Check out the links on the screen if you want to know more details after watching this section. We will only focus on some configuration aspects, for instance the QPA, which focuses on the graphical backend that we have. So for the graphical backend, you have several options. Specifically for Linux, you have EGLFS, which uses OpenGL in full screen, so it doesn't have any notion of Windows and doesn't require a window manager. You also have Linux FB and DirectFP, which are similar and also work without a window manager. XCB uses the X11 protocol, and similarly, Wayland allows Qt applications to connect to the Wayland compositor. There are also many other customization parameters, such as the input system to use. You have several libraries such as libinput, libevent, touchscreen support, network encryption support, database, which is in this case is SQL support, SQLite, and so on. Okay, I think that's enough in terms of background information. In the next section, let's start with the actual integration. So the first thing we need to do is add a meta layer which adds Qt support in our sources. As usual, if we don't have a specific layer in hand, we search for one through the officially supported Yocto layers or the Open Embedded Layer Index. In this case, I'm going to go to the Yocto project website, look at the compatible layers, search for a Qt5 layer, which is the latest release of Qt. We do find one, and if we investigate through the branches that exist, we see that THISDIR, which is the Yocto release that we are working on, is supported, as well as Warrior, which is the latest release, which I'll probably make a video on later. So let's go ahead and clone this layer and add it to our bblayers file. In the previous videos, we named the layers directory differently. In this case, I'm naming it sources. I'm going to check out that branch just to be cautious. Okay, I'm going to source the pokey script to our RPI build folder. Right. I'm going to edit the conf file, layers file, our layers. Make sure it works for a recipe name. Just to make sure that LA is correctly passed. Typo. Okay, so it is detecting the layer correctly. So next we should add some application to test Qt. Luckily, Qt 5 contains some example applications, and in our case we will be baking in a well-known sample application called cinematicexperience. You can choose any one of these. So let's go ahead and open our image recipe and edit it to include that application. Sample layers. For images. Line feed at the end. Okay, so we should be ready. So I'm going to go ahead and bake the image. I don't recommend you do that just yet because these changes and building Qt will bring up a build that will generally take more than an hour to complete. So I recommend you wait until the end of this section because we will have to make some changes so you don't have to compile it more than once. So the image was built successfully and I've already flashed it and booted up the Raspberry Pi. What we can do next is to execute the application. There's a utility which is OE package data, and it has an argument called list package files, which lists all of the files that a package installs in the rootfs. In case it's cinematic experience, just so we know where the binary is located. So as we can see, everything is located in /user/share. I'm going to open an SSH session so we can execute the application. You can do this through the serial port or directly with the keyboard. Okay, so we get an error here, and it's because there is no QPA plugin configured, and it does suggest that there are some available, but none of these actually produce an image on the screen. If you go to the work directory of the qtbase application or package, you can find a file which is called config.summary, which contains all of the configurations options that were used during compilation. And if we investigate this, we actually get a warning telling us that no QPA platform plugin was enabled. And if we investigate further, we can see that neither EGLFS, which is the one that we are interested in, or an alternative could be Linux frame buffer or direct frame buffer. From my impression, I think these are either they don't have odd hardware acceleration or they are more primitive than EGLFS. Anyway, why does this happen? And the reason for this happening is that if we investigate our distro definition, we actually see that we disabled OpenGL. Take a look. So it's in the list of the features to remove. So the easy thing to do here, obviously, is just pass it to the features to include. Now that we've added OpenGL to our distribution features, the package configuration of Qt should pick up those changes and enable the EGLFS QPA, which should be enough to run our application. What I want to do is customize the Qt base configuration by creating a recipe that appends to the base recipe. In this way, we are certain about the configuration of Qt that we end up compiling. The Qt for Embedded Linux website has many more details on how to configure your platform, including the QPA configuration through environment variables, as well as input, font, and other tweaks. In our case, I will only set the default QPA by creating a file that will export that variable in /profile. In order to create a recipe that appends to the qtbase recipe, it's probably useful to look at the original recipe. We can get an idea of what we can configure by looking at the recipe. For instance, we can see here that the OpenGL support is done by inspecting the distro features list and verifying if it contains the OpenGL keyword in it. If so, Qt ends up having the GL option enabled. Similarly, that also happens for X11 and other verifications. So we can see a bunch of configuration here and that we can use and customize in our own recipe. So let's go ahead and create it. I'm going to create it inside the recipes core directory. So it's named qtbase_get. So I'm going to create a qtbase_%.bbappend. And also since we will be creating a file that will be situated in Etsy profile, I'll also go ahead and create that. So it's going to call QPA. Let me see in the actual target. We can see that the files, the permissions of the existing files there, and we can see that there are already two files under Etsy profile.d. So we can create a similar file, but for the Qt. And we can go ahead and populate it right now. So this variable, GLFS. Go ahead and populate the recipe. So we are going to customize the qtbase configuration. So what we can choose here is the GL option. Package. Also add the direct FB. EGLFS. GLES2. And you have other options. Depends on what you want. For instance, you might want to log into the journal. Systemd. Go ahead and try that. Now we also want to set the default QPA platform. So qtbase.sh. Also have to customize the install method. Okay, so I think that's about it. Now another thing that's easy to forget is that initially we set the GPU memory to the minimum value, which is 16 megabytes, and that's probably not enough for full HD. So I'll go ahead and change it to 256. So that should be enough to run the cinematic experience application. I'm going to go ahead and rebake the image, and I'll be back once that's done. So I've built the image and flashed the Raspberry Pi and booted it up. We can try again to run the application. I'm going to SSH into the target. I'm going to cd into user share cinematic experience and run the application. Alright, so we can see it ran correctly. This is just an example application, but the performance is acceptable, I guess. So another addition that we can do is to create a service file that will boot this application, just as an example. So let's do that next. I'm going to go to the recipes apps folder inside our layer directory. And I'm going to create a directory for cinematic experience. You can actually see the original recipe name. There was an examples, cinematic experience. So this will have a percentage sign, append to run. So what we'll have here is inherit systemd. Okay, so I've created the file and also the service file. I've gone ahead and created the service file. One thing I did have to do is set the environment variable for the QPA platform, because the service doesn't run under the same environment since it's not a logged in user, so it doesn't get the context of the profiled variables. I'm going to rebuild the image. See if this works during boot. So it seems like the service file is working fine. So I'll see you on the next chapter, where we will discuss the generation and usage of the SDK that supports Qt. So what we're going to do in this chapter is basically repeat the regeneration of the SDK, but before that we have to edit our image recipe so it includes an additional line from the meta Qt5. Additionally, I'm going to add rsync because it's useful in QtCreator for the deployment of our app. Another addition which might be useful is to add tools debug to the extra image features, and this is essentially to get GDB server, which enables us to do remote debugging, which I'll demonstrate later using QtCreator. So for that we just need to add tools -debug, and now we can generate our SDK. Okay, so now we repeat the usual, the same command that we did in the Create SDK chapter. And this will take a considerable amount of time. I'll be back once this is done. Now that our SDK is finished building, we have to install it in our host machine, which means outside of Docker. So I'm inside the build folder /tmp deploy SDK, and we have an install script, so I'm going to go ahead and execute it. I'm going to opt for the default installation path, which is in /opt. Now that we've installed the SDK, there's a script, an environment script that we have to source to set up the cross-development environment, which is inside the installation directory. So I'm going to go ahead and do that. Then we can call up QtCreator. I'm going to create a project just as using one of the examples. So I'm going to call it SDK Hello World. Qt 5.11, which I think is the version that we have in Yocto. Now we need to add a new kit. I'm going to go ahead and do that. Create a new one, call it Yocto. We have to create a new device. This is used for the deployment, remote deployment. So you have to know your device IP address, username, root. We can then deploy the public key, so we don't have to type the password every time we deploy something. So I've gone ahead and booted up the device. Don't forget that you have to rebuild the firmware if you haven't after the addition of the debug tools. And deploy the public key. Okay, so if you get this error, it means that your known hosts has been pre-populated with this specific device. So what you have to do is actually remove it from your known hosts file. So you just need to find the entry in this file and in regards to that specific IP address and remove that line. Okay, so I've done that. Let's try again. Type a password, which is Tor. Okay. We do get one error, which is because we don't have SFTP support because we're using Dropbear. But since we installed rsync, QtCreator also has support for that. Okay, so our device is set up. We can continue on defining the kit. So now we can choose a Raspberry Pi. Need to select the rootfs, which is under the SDK directory, the x86 one, because we're going to do cross compilation. We need to add new compiler entries for GCC. I'm going to name them Yocto. I'm going to name everything Yocto. For this one, user bin. And it's we're using glibc, so I'm going to use the GNU one. Just choose GCC. I'm going to use this for C++ also, so I'm going to copy it. So add an entry for C++. I'm going to name it Yocto also. There we go. Debugger, same thing, search for it. Name it Yocto. For the path, it's probably in user bin. So gdb. Oh, it's actually also part of the toolchain, sorry. For the CMake, we also need to add QMake. Yocto, once again. And this one is in user bin, probably. Go back to our kits. Seems fine. Okay. I'm gonna go ahead and SSH into the device and stop the cinematic experience app. Okay. I'm gonna choose this. Actually, you might also want the desktop kit. You want to test things locally before deploying. Okay, I'm gonna choose the Yocto device kit. See if it's built. Okay, it seems like it built fine. I'll try and execute it. Okay, it seems like deployment isn't working. Okay, so the reason it's not working is because in the kit definition, I didn't change the compiler to use the Yocto one. Let's go ahead and do that, and also the GDB, anything else. There should be a Yocto one. So try that once again. Still giving off the same error. Everything's correct. Oh, it didn't save the changes. This. Fine. Okay, remote process crashed. Let's try and execute it through SSH. So it seems at least that the format is correct. Okay, so there's actually a Qt module that's missing, and we need to add this to our recipe. So it's Qt quick controls. Go ahead and edit our image recipe. Actually open up the Qt recipe. We'll go to the Qt layer. Okay, so we have Qt quick controls here. I'm going to install this package. I don't know if it's only version 1, so I'm gonna go ahead and also install version 2. So we just need to regenerate the example image, flash it again, or alternatively you could async yourself manually the libraries to the target, but regenerating the image is just easier. Fix this typo. Okay, so the rootfs has been rebuilt with the libraries, the Qt controls libraries. So I'm going to try it again and launch our application. Okay, so this time it seems to be working. Now I'm going to try and do some debug operation. So let's go to the sources main file, put a breakpoint here, for instance. Okay. Try and see if the breakpoint works. Yep. Okay, so I think that's it for this chapter. I hope you guys found it useful. If you have any comments, just leave them. I'll try and answer as soon as I can. Thanks, guys.